Let's now consider this probability problem that we need a Venn diagram to solve, or is made easier with the use of a Venn diagram. The probability of event A is 0.2, the probability of event B is 0.3, and we know that probability of A or B is 0.4. Use a Venn diagram to find these quantities. Well, the first one, we actually don't need a Venn diagram. We know that the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Okay, so the probability of A or B is given to be 0.4. The probability of A is given to be 0.2. The probability of B is given to be 0.3. So the only thing that's left is the probability of A and B. And so what has to happen is that the probability of A and B must be equal to 0.1. Okay, this can be visualized fairly nicely with what's called a Venn diagram, which let me draw down here. So let me draw a big box, and in here we draw one circle to denote event A, and a second circle that denotes event B. And inside of these circles, let me mark the probabilities. So this one is supposed to be event A, this circle, and this circle is supposed to be event B. The probability of A and B is 0.1, so that's the intersection of these two circles, 0.1. Now this entire left circle is supposed to be equal to 0.2, which means there's got to be 0.1 left over in this part, so 0.1 plus 0.1 gives me the total of 0.2. Likewise, the total of this circle must be 0.3, and that leaves 0.2 for this circle, so that 0.1 plus 0.2 gives me 0.3. Notice that if I add these three up, I get 0.1 plus 0.1 plus 0.2, which is 0.4, which is what I expected to be the area of A, the probability of A or B. That's 0.4, and that leaves us 0.6 here on the outside, where neither event A nor B happens. Okay, so this one we found to be 0.1. The probability of A and not B. So A happens, but B does not happen. That's this part right over here. A happens, but B does not happen. That's this part that I'm kind of outlining with the cursor over here. So that's also 0.1. The probability of A does not happen and B does not happen. So that's going to be everything on the outside, so that's 0.6. So those are fairly straightforward. The only one that's a little bit complicated is the probability of A given B. So for that, let's do some calculations over here on the side. So I know that the probability of B and A is equal to the probability of B times the probability of A given B. That's my multiplication rule. The probability of B and A is 0.1. The probability of event B is 0.3. And that's multiplied by the probability of A and B. And so what has to happen is that the probability of A given B is going to be equal to 0.1 divided by 0.3, which is 1/3. So our final answer is 1/3. Now the visual interpretation of this is that if I take a look at the B circle, if I know the B circle happens, 1/3 of the B circle overlaps the A circle. So there's 0.1 over here and 0.2 over here. So 1/3 of the B circle overlaps the A circle, and that's the number that came out over here.